Hello, everyone, and welcome back. Today, we are going to be talking about finding the point of intersection of two lines by graphing. Now, in the next course you take, in the grade 10 course, we'll actually learn how to find the points of intersection using algebraic methods. However, for this course, you don't have to be able to do that. All you need to do is be able to graph two linear equations, which we already in the last lesson talked about how to graph one, and then put the point of intersection. So I also want to point out here that solving a system of equations means finding the points, means finding the places where all equations intersect. And I'm being purposely vague here, and I'll tell you why I'm being purposely vague on that. It's because sometimes, in the future when we get to university level linear algebra, that sort of thing, and we have like different planes and that sort of stuff, we can actually have an entire line as our answer to our system of an equation, for example, or when we're doing, even polynomials later in high school, sometimes there's 2 points where the equations meet, right? So there's 2 points that are both solutions to the system. Sometimes there's infinitely many solutions to a system, things like that. So basically, solving a system broadly just means finding the places where the equations intersect, and those could come up with a wide range, in the future. However, that said, for the sake of today and just grade 9 in general, there's only going to be one point of intersection for all of these graphs, right? Pretty much the the results, probably most of the time, the vast majority of the time, when we have two lines, we're asked to solve for what is the where do they intersect or solve the system. The answer is just going to be 1 point. Now, technically, there are two other possibilities, and I'm actually going to go over all three possibilities. But let's first start with the most obvious, most common one. So, for when it comes to solving a linear system specifically, there's only three things that could happen. And two of them are pretty rare. There's one main thing that happens most of the time. Okay? So, the first thing that could happen is that they intersect at one point. So there is one solution. There is one solution, which means that the lines intersect at only one point. Okay? And that is the most common solution that happens almost all the time, except for these two exception cases where this does not happen. But in every other linear system, this does happen. So this is what you'll expect when you're solving a linear system, is the answer to be a point vast majority of the time. So what are those exceptions? Exception one is if the lines are parallel. If the lines are parallel, then there are no solutions. And why not? Why are there no solutions if the lines are parallel? Well, if the lines are parallel, that means they have the same slope, right? So they're going, up or down at the same rate. And so therefore they're never going to meet one another because they start in different places and then they do the exact same thing. They're carbon copies of each other, but just placed in different spots. And so they never actually meet one another. And so I'm going to mention too for that, if the lines are parallel, I'm going to just say parallel equals same slopes, okay? Because if the slopes are the same, then that means the lines are parallel. And if the lines are parallel, that means that the slopes are the same. So these are some categories we need to make sure we know. But yeah, basically, if the slopes are the same, then there are no solutions. But there is one exception to this. If the lines are actually the same line, if the same line is repeated, twice, then there are infinite solutions. Right? So if I have my grid here and then I have just the same line twice like this, or any line that's just the same line twice on top of each other, then there are no solutions. Or sorry, then there are infinite solutions because any of the points on that entire line, which there's infinitely many points on a line, is going to be a solution. So basically, if the equations are both actually the same equation, or if the slopes are the same, so if those m values are the same, then it will not be the case that you'll get a point. But as long as those two things are not, you know, are not the case, then you're good. Then this does apply absolutely. So do keep that in mind that if the slopes are the same or if the equations are the same, then you won't get a point as your answer. But most of the time you will get a point as your answer, right? How often are your slopes the same or the equations just the same thing? Well, not very often. So generally speaking, the solution they're looking for is just a single point, and that's it, you're done. Okay, so let's go back to these examples and let's graph these systems of equations and find out the answer. Now, already just looking at these systems of equations, none of these pairs have the slope is the same, and also by extension of that, none of these are just the same equation twice. So for all of these equations, all four of these, we're going to just get a single point as the answer. Okay, so let's do A first. I'm going to do, let's use this blue and this purple color. So for the first one, I'll use blue, and for the second one, I'll use purple. Okay, so for the blue equation, we're going to start at -6. So 1, 2, 3, 4, 5, 6. Oh, and then our slope is 5 over 3. So that means rise is 5. 1, 2, 3, 4, 5. And we're going to go over 3. So therefore, it's going to look like that. So there's our line. Okay, now let's do the purple one. So the purple one is a half x plus 1. So we're going to start with our first point as plus 1 right there. And where's our next point? Well, our slope is 1/2, right? So rise would be 1 and run would be 2. So it would be there like that. And then we'll connect the dots here. There we go. And looks like they meet. Where do they meet? They meet right there. Right there. And that's at 6, 4. So therefore, the solution to the system or the point of intersection, either one is good with me, the solution to the system is 6, 4. And there we go. All right. Okay, let's move on to B. So let's do the same thing as before. Let's do purple and blue to kind of distinguish them. So first of all, we have -4 over 3x minus 8. So let's go to -8. 1, 2, 3, 4, 5, 6, 7, 8 is down there. And then what was our slope again? It was -4 over 3. Okay. So that means that it's going to be -4 for our rise and 3 for a run. But the thing is, that's going to get us off the grid. So I'm actually going to switch that because we can. We can put it anywhere we'd like. Let's do rise is 4 and run is -3. So rise up 4, 1, 2, 3, 4. And then -3 over like that. Excellent. Okay. And now we are going to do the second one, which is -1/3 x and then -2. So we have minus 2 there, and then negative a third for x. So therefore, our rise is negative 1, and our run is going to be over 3 like that. And then let's connect it up. Oh, I erased them. Okay, that's okay. I remember where they were. They were here and here. Okay. There we go. Let's extend it this way. Not that it actually matters, but let's extend it this way anyway. Okay, so it looks like it intersects right around right there. And that actually makes sense with this one too, because if we go another 3 and up 4, 3 and up 4, it actually, yeah, it does get to this point right there. And so that is going to be our answer. I guess the drawing there is not the best for the blue one, but it should be there, which is good. So therefore, our answer would be minus 1, 2, 3, 4, 5, 6. So negative 6, comma 0 is the solution to the system. There we go. Okay, let's do another one over here. Okay. So this one, we have negative 3 over 4x plus 2. So let's start by plotting the point 2. And then negative 3 over 4. So I'm going to go down 3 and over 1, 2, 3, 4, like that. This time I'm going to draw it accurately. Let's do it again. Negative 3 over 4. 3, 3, 4 to the negative. 3, like that. Okay, excellent. And let's connect all those dots. Excellent. All right, and let's do the next one, which is 1/2 x minus 8. So let's start at negative 8. 1, 2, 3, 4, 5, 6, 7, 8 is down there. And then we have a half. So its rise is 1, run is 2. So there, 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 and there. There we go. There's our point of intersection right there. That's our solution. Good. Okay. So therefore, the solution to the system looks like it's negative 3, 6, 8. And then down 1, 2, 3, 4. Like that. Awesome. Okay. Let's move on to D. Okay. So let's start with negative 8, right? Because that's our y-intercept. So let's start there. Going 1, minus 1, 2, 3, 4, 5, 6, 7, 8. And then the slope is 3. So that means 3 over 1. So rise is 3 and run is 1. So we'll have points here, 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 here. There we go. Let's draw a line through all of them. Good. And then let's do the second one, which is the purple one, where we have negative 2x plus 7. So that means we'll start at plus 7. So 3, 6, 7 is right there. And then we have negative 2 as our slope. So that means we'll go down 2 and over 1. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Here, 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 here. Awesome. Okay. And now let's put a nice line through all of them, even though I think we already solved it. We already know what we're doing as far as solving is concerned. All right, so therefore the solution is 3, 1. Very good. So as you saw with all these examples, since we didn't have any examples throughout this whole thing where the slopes were the same, all of them just, ended up with there was one point of intersection. Now, you might be asking, well, what about points of intersection that aren't as easy to see on a graph? And that's where using the algebraic method comes in. And that is why I feel that the algebraic method is a far superior method to this one, because this one we have to, specifically choose equations that are going to meet at a nice point, not equations that are not really going to meet at nice points, but still do meet at some point. And so that is a topic we'll learn in grade 10. However, in terms of the grade 9 curriculum, this is all you've got to be able to do. You just need to be able to solve systems where graphing the two lines and figuring out which point it is they meet at is enough. And in this case, we did that for all these situations and it was enough there. So, very good. Good work today, and I will see everybody next day. Bye, everyone.